Hello, dear colleagues. Thank you for being here. My name is Ganna Kostenko. I'm a junior researcher from General Energy Institute of National Academy of Sciences of Ukraine. Today I will present the results of our research on SWOT analysis of electric transport and vehicle-to-grid implementation for power system sustainable development in the terms of Ukraine. The electrification of transportation is considered a key requirement for the Paris Agreement implementation. As part of this effort, there is a gradual replacement of internal combustion engine vehicles with electric vehicles worldwide, including Europe and Ukraine as well. Over 100 countries, including Ukraine, have joined program for electric vehicle development. This transition aims to reduce carbon dioxide emissions. The decrease in cost of battery technology, along with increased battery capacity and driving range, has contributed to the steady growth of electric vehicles. This growth will inevitably put strain on the electric grid. Therefore, the widespread adoption of electric vehicles and the development of charging infrastructure should occur in a synchronized and coordinated manner with the transformation of power system. According to the International Energy Agency, the global electric vehicles fleet surpassed 10 million units in 2020. By 2030, it is projected to reach 150 million units, and by 2040, 300 million units. Over the past 10 years, significant progress has been observed in the adoption of electric vehicles in Ukraine. According to statistical data, in the beginning of 2023, there were almost 47,000 registered electric vehicles in Ukraine, with more than 13,000 being registered during last year. The Nissan Leaf remains the most popular model in Ukraine, with nearly 40% share of the electric vehicle market. The Ministry of Infrastructure of Ukraine has presented the transport strategy, which aims to have at least 250,000 electric vehicles in Ukraine by 2030, with municipal buses and taxis being fully electric. With the increasing share of electric vehicles, the demand for electricity required for battery charging will significantly increase. This may result in uneven electricity load due to the rise in evening peak demand and put additional strain on the distribution infrastructure. Integrating electric transportation into the existing power system requires careful planning and optimization. This study aims to analyze the opportunities and threats for the development of electric transportation in Ukraine, as well as to examine its interaction with the power system. State support policy in Ukraine. The experience of many countries such as Norway, Netherlands, Germany and others shows that government support policies, incentives and benefits can significantly accelerate the adoption of electric transportation. In 2022, two laws were adopted in Ukraine to stimulate the development of the electric transportation industry. The joint project between Energoatom and Ukrgasbank was initiated to create a national network of fast charging stations. And finally, in October of 2022, the concept of the smart grid implementations in Ukraine until 2035 was approved. It includes several tasks directly related to electric transportation. The process of charging an electric vehicle serves as a point of interaction between the transport and power sectors. It includes charging infrastructure, charging strategies, and auxiliary services to the power system that arise from the application of certain strategies and technologies. Charging infrastructure in Ukraine. One of the necessary conditions for the growth of electric vehicles is the development of the charging infrastructure. 70% of private electric vehicles prefer home or workplace parking charging. In Ukraine, in the beginning of 2022, there were almost 7,800 charging points, of which 76% were slow charging with alternating current and 24% were medium or fast charging with direct current to the battery. Usually, charging infrastructure is assessed by the number of electric vehicles per public charging point. In Ukraine, this indicator was 4.3 per electric vehicle, while the average in Europe was 6.8. About vehicle-to-grid concept. With the widespread adoption of electric vehicles, significant amounts of electrical energy can be stored in their batteries. According to research, private electric vehicles are not in use for the majority of the day. Nearly 90% of time it is staying parked. It is practical and feasible to return the accumulated electrical energy in their batteries back to the grid and utilize it to balance the load curve without compromising the primary transportation function of the electric vehicles. This slide presents the vehicle-to-grid concept both in terms of individual vehicle participation and through an aggregator, which can be more efficient and beneficial for everyone. However, to achieve this, it is necessary to regulate the rules for aggregator participation in electricity markets. Vehicle-to-grid enables several beneficial tasks to be performed: frequency regulation, peak load reduction, consumer benefits, and energy reserve. About battery degradation. This slide depicts the dynamics of battery capacity degradation. Usually, manufacturers provide an 8-year warranty, and as shown, the battery capacity decreases by 35% over 8 years of vehicle usage. The majority of electric vehicles in Ukraine, around 90%, are used and approximately 5-6 years old. Battery degradation reduces the driving range of the electric vehicles, increases charging time, and diminishes the overall battery performance. Battery degradation is influenced by the age of the electric vehicle, temperature conditions, especially high temperature, operation at high, about 80%, and low, about 20% charge levels, as well as frequent use of fast charging stations. Based on the research material, we have conducted an analysis of the internal and external factors that determine the development of electric transportation and vehicle-to-grid implementation in Ukraine. For this purpose, the SWOT analysis was used. This slide presents the internal factors, such as strengths and weaknesses. Among the strengths can be highlighted environmental friendliness, reduction of air pollution, especially in big cities, sustainable growth of the electric car fleet in Ukraine, electricity is much cheaper than fuel, favorable climate conditions, high share of private car ownership, and others. Among weaknesses can be highlighted high price for new electric vehicles and high price for replacing batteries. Low share of electric vehicles in the country's car fleet. 90% of electric vehicles are used with partially degraded batteries. The need for daily charging, the need to determine the time and place for charging. Lack of own production of electric vehicles, batteries, and vehicle-to-grid devices in Ukraine, and others. This slide presents the external factors that contribute to the development of electric transportation in Ukraine, such as opportunities and threats. Among the opportunities can be highlighted reducing of carbon dioxide emission, reducing of use of natural gas and petroleum products, and dependence on energy import. Implementation and development of smart grids. The growing popularity of electric vehicles. Possibility of using of electric transport as a consumer regulator of electric load, and as a distributed storage of electricity. Use of battery of electric vehicles as a power reserve in emergency situation in the power system, and others. Among the threats can be highlighted probable rising of electricity prices, outflow of young solvent population due to war or economic reasons, large secondary market for more affordable cars with internal combustion engines. Charging electric vehicles directly depends on human activity and increases the evening peak of electricity consumption. Uncontrolled charging causes a number of negative effects in the power system, grid stability and electricity quality, and others. This slide presents the significance of charging strategies and their impact on the daily load curve. The red line represents uncontrolled charging, also known as charging by demand, with a characteristic evening peak. The blue line represents managed charging using tariffs or unidirectional smart charging, vehicle one grid, which dynamically adjusts the charging time and speed based on tariffs and grid loads through sensors and controllers. The green line represents bidirectional intelligent charging, vehicle to grid, which not only charges the electrical vehicle but also returns electricity to the grid during periods of energy shortage to support peak power. The impact of charging strategies modeled for Belgium. Belgium's electric load graphs clearly shows the regulatory capacity of electric vehicles with smart grid concepts. The impact of vehicle one grid and vehicle to grid smart charging on the electric load schedules represented on this slide, which shows the simulated average daily electric load from EV charging in Belgium for 2030. It can be concluded that in Ukraine, vehicle-to-grid technology is still in its early stages, with a limited number of pilot projects. However, the potential benefits of vehicle-to-grid in Ukraine are significant, including the ability to reduce energy costs, improve grid stability and reliability, and support the integration of renewable energy sources. To fully realize the potential of vehicle-to-grid in Ukraine, there are several challenges that must be overcome. These challenges include a lack of infrastructure and investment, regulatory barriers, and the need for more research and development to optimize the technology. Overall, while there are significant challenges to overcome, the potential benefits of vehicle-to-grid in Ukraine are substantial, and efforts to develop smart technologies should continue to be one of the priorities for power sector. For more detailed information about the subject, I suggest you to get acquainted with our papers. Thank you for attention.